All right, welcome in, Mr. Jorgens here. We're going to continue our work with section 9.1 with simplifying radicals today. This is going to be part 2. We started off with part 1 last time. Stay tuned. There will be a few questions for you to answer along the way, and make sure you're ready. All right, we're going to start with 2 little review questions here just to remind you what we were doing yesterday. We need to be able to simplify square roots when they're not even. Obviously, at a square root like 49 is just 7 times 7, so you just say square root of 49 is 7. But if you have something like 48 that does not go in evenly, then we need to break it down with the tree. So the way we did that yesterday is we thought of 2 numbers that multiplied to 48. You could pick 4 and 12, or 6 and 8, or 2 and 24. I'm going to pick 6 and 8. Then we continue breaking both those numbers down because neither of them are prime, right? I can find factors of both 6 and 8. For 6, I'd have 3 and 2. For 8, I'd have 2 and 4. 3, 2, and 2 are at the end of the branch because they're prime numbers. Can't go down further, but 4 is 2 times 2. And then I'm looking at all the numbers at the end of the branch and seeing how many pairs I have. I have 1 pair of 2s, a second pair of 2s, and a single 3. So the single 3 stays on the inside. Both 2s are going to come outside and multiply together. So I'm left with 2 times 2 is 4 on the outside, square root of 3 as my simplified form. All right, go ahead and try one before we get going on some new stuff, just so you make sure you remember how to do this. Simplify the square root of 63. Again, that's not a perfect one. If it was 64, I could do 8 times 8, but I can't do that with 63. So go ahead and break down that one down with a tree and enter your answer when you're ready. All right, so breaking that down, I'd have a pair of 3s and a single 7. 3 on the outside, 7 on the inside. Hopefully you picked 3 square root of 7 as your answer. All right, so our first new example of kind of part 2 here is an example with a different index. This is a cube root of 128. So the goal here is we're going to break down the cube root the same way we broke down a square root, except we're going to be looking for groups of 3 numbers in common in the tree rather than just pairs. So we're starting with the number 128 this time. 128 is a big number. You might not know right away what will work for it, but it is even. So if you ever have an even number, you can always divide it by 2. And when I divide by 2, 2 goes into 12 6 times. 0 left. 2 goes into 8 4 times with none left. So 2 times 64 would then make 128. And then 64 is 8 times 8. Now I can't circle the pair of 8s because I actually need a group of 3 in order to pull something out. So I can't circle anything there. My 8 can be 4 times 2. And then my 4 would be 2 times 2. And same thing again, right? I have a 2, a 4, and then the 4 becomes 2 and 2. Now I'm looking for groups of 2, and groups of 3. So I have 3 2s here at the end of branches, and I have 3 2s here. So I have 2 groups of 3 2s. So I can pull 2 2s outside of my cube root. Then I have 1 2 left over that doesn't have any group to be a part of, and that 2 is going to stay on the inside. So I'm left with 4 cube root of 2 as my answer on this one. All right, so that's the process for calculating out a cube root, break it down, look for groups of 3 rather than just groups of 2. Alright, here's one for you to try, cube root of 54. Go ahead and break down that cube root, simplify it, and enter your answer when you're ready. Alright, so 54 is 9 times 6, 9 is 3 times 3, 6 is 3 times 2. So I got those 3 3s, so I can pull 1 3 on the outside, hopefully you did that. And I have 1 2 left. And that'll stay on the inside of the cube root, so 3 cube root of 2 would be our answer on this one. Alright, a second thing that we need to talk about today is something called rationalizing the denominator. So that's going to be our directions. Here, rationalize the denominator of, let's say, 5 over square root of 7. Now, when we're rationalizing the denominator, what that means is we cannot have square roots in the bottom of a fraction. So the denominator of a fraction cannot have a square root down there. And so if there's one there, we're going to need to remove it. And the way we can do that is by multiplying it by itself. But in order to have it stay equivalent, because I'm going to want to write this as equal to something, I need to multiply by 1. So multiplying by root 7 over root 7, the same square root over itself, is a friendly 1, right? Root 7 over root 7 is another way of saying 1. So what I can do here is I can then multiply across, so 5 times root 7 is just 5 root 7. And then in the bottom, root 7 times root 7 is root 7 just squared, which would just be 7. And I'm left with 5 root 7 over 7. And this looks more complicated, but it's actually the simplified form because I don't have a square root in the denominator. So just the simplified form would just be 5 root 7 over 7, right? So if you ever have a square root in the denominator like that, where it's just one part like square root of 7, that's the way you're going to get rid of it. All right, so go ahead and try part B. For part B, we're going to do 3 divided by square root of 11. So go ahead and rationalize the denominator to simplify that and enter your answer when you're ready. All right, so again, I'm going to do it the same way. I got to multiply by root 11 in the bottom, make it a friendly 1. 3 times root 11 is 3 root 11. Root 11 times root 11 is just 11. Same thing as the 7s over there, right? Root 11 times root 11 is root 11 squared, which is just 11. All right, so that'll get us to 3 root 11 over 11, which is going to be our answer for that one. All right, this gets a little trickier with cube roots because I can't just automatically multiply by the same thing in the bottom, because this time cube root of 9 times cube root of 9 would make cube root of 81. And 81 as a cube root actually doesn't break down evenly. It'd be 9 times 9 and then 3 and 3, 3 and 3. And so I'd have 3 root 3, which isn't going to help me, right? So if it's a cube root in the bottom instead of a square root, I can't do it in the same way. What I do want to do is I want to multiply by something. I have to be a little bit clever about my choice here. That gives me a cube root that's going to come out evenly. So I want to kind of know my perfect cube. So 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. And I want to kind of get 9 to multiply up to one of those things, like 8 or 27 or 64. And I think I can get 9 to 27. And the way I'm going to get there is by doing 9 times 3 is 27. So if I multiply 9 by 3, then I end up with a 27 in the bottom. And when I end up with a 27 in the bottom, the cube root of 27 is just 3. And now my denominator is rationalized, right? I got rid of that root. Again, to multiply by a friendly 1, I have to make it multiplied by a cube root of 3 in the top, and I end up with 2 cube root of 3 there in the top. So I'm left with 2 cube root of 3 over 3 as my answer there. Let's have you try a very similar one here. So let's rationalize 5 over cube root of 32. Again, we're going to try to get 32 multiplied up to either 8 or 27 or 64 or 125. And that will help us simplify it just like we got that 9 multiplied up to 27. Go ahead and try that one on your own and enter your answer when you're ready. All right, so I think 64 is going to be the way to get there. And we'll multiply by cube root of 2 because 32 times 2 is going to make, that should be a multiplication symbol there. Let me be clear about that. Cube root of 64 on the bottom there. And then in the top, 5 times cube root of 2. And then the cube root of 64, 64 is 16 times 4, and 16 is 4 times 4. Again, that's going to go in evenly because right here, 4 to the power of 3 is 64. So then the cube root of 64 would just be 4. So 5 over the 5 cube root of 2 over 4 would be our answer there. All right, so hopefully that kind of ties together what we need to know about section 9.1 here. There's a second big ideas assignment for you to try, so go ahead and work through that and let me know if you have any questions. Have a good day.